Earth and the Moon are not getting in the way. So here's a picture of the spacecraft when it was still in the assembly room. It's covered with shielding to protect it. There are a number of solar panels on the outside that you can actually see better in here. These are solar panels right here. That's what's used primarily to power the spacecraft, is light from the sun. The camera, the spacecraft is really just a big digital camera. This thing here is 21, or actually 42 charge coupled devices. A charge coupled device is the thing in the back of a digital camera. And there are 42 of them. There are 2 of them in each of these 21 boxes. They're on a curved focal plane so that each one of them is in focus. This is called a prime focus camera. So basically what Kepler is an enormous camera. But rather than taking pictures, although it does take pictures, the main aim is to measure the amount of light that's hitting the camera at any given time.
这边讲的是太空那个 Kepler 太空望远镜啊，所以有几个问题，就刚才讲哈勃太空望远镜会有被地球挡到的问题，对不对？所以第一个问题各位应该想到，你要设计这样一个怎么样一个太空望远镜，它不会被地球挡到。第二个刚刚讲到的是这个望远镜的一些特色，各位看到右上角这个照片啊，是一个人工程师跟这个数位相机，各位将来有任何机会啊，任何你家里有东西坏掉了，都不要随便丢掉。我的原则就是要拆完看过以后再把它丢掉。所以你如果有数位相机坏了，就把它拆开来，你就会发现你的数位相机上面的感光元件只有这么大，就很小一片，用那个来照相，那你可以看看这个的感光元件有多大。那重点还不是大。因为做不了那么大，所以它要拼起来嘛，还有好多感光元件把它拼起来。重点还是它要很稳定、很灵敏。它一共有42个科学用的 CCD 就是感光元件啊，它把光线变成电子讯号啊。然后呢，温度呢保持在摄氏零下85度。这一个，然后它是 NASA 所有放到太空的任务里面最大的电子相机。最大的数位相机，它一共有9500万个画素，这个不多，因为你现在任何一个家里用的常常的那个都有1000万个画素，对不对？所以9000万并不多，在于说要稳定，然后要放在太空的环境里面，还能够侦测很小的光的变化，是挑战是在这里。I explained to them this is not a huge camera in terms of devices.
Yeah, that's right. It's not actually, even though this looks big, this is not a very large telescope. The opening here is about one meter across. That's a medium-sized telescope. This is where the Kepler spacecraft is pointing. Kepler looks at one field all the time. It doesn't scan all over the sky. It looks at one part of the sky. It looks at a little patch of sky between Cygnus and Lyra. So this is the plane of the Milky Way. And this is where the Kepler focal plane is oriented. You can see it here. These are the 42 different detectors. Cygnus and Lyra are shown here. I'm going to ask a question again. Why would Kepler look near the plane of the galaxy? Why would Kepler look, if this is the Milky Way, why would it look there?
我们教授问大家一个问题啊 ，Kepler 只看一个地方，它不是东看西看，它没有扫描天空，它只看一个地方。这个地方在天鹅座，那个十字啊，就一只鸟的样子。上面那个右上方那个 Lyra 就是织女星，所以大家知道夏季大三角，对不对？天鹅座、织女星、牛郎星、天津四。为什么？假如你是这个任务的科学家，你要只看一个地方，为什么要看一个这个地方，在银河盘面附近？You want to answer now？ 有没有要试图回答这个问题？来，请。
银河旁边的位置，那个星星的密度最大，然后只看那个地方的话，就是工作效率会比较高。
His answer is because there are many stars there, and so it gives the highest efficiency.
Correct. There's another related question that I'll answer, which is, why would Kepler not look? Kepler doesn't look exactly at the plane of the galaxy, but it looks a little bit above the plane of the galaxy. The reason why it doesn't look at the plane of the galaxy is that it doesn't want to be seeing giant stars on the backside of the galaxy. So if you look a little bit above the plane of the galaxy, you don't see those distant giant stars. And there's also, you don't want the thing to be too crowded with stars. By looking above the plane of the galaxy, Kepler can look at can monitor about 1 million stars at once. And out of that, they pick about 170,000 stars that they'll carefully monitor almost continuously. So I'm going to ask one more question. Why is Kepler looking in the northern hemisphere?
Kepler 只看一个地方，它同时可以监测100万颗星。刚才后面教授特别也问了下一个问题，就是说，如果星星多的话，为什么我们不直接看到银河盘面上？对吧？那星星最多了，为什么要稍微远离一点点？这个是比较天文的背景，就是说，因为你真正看银河盘面的话，有很多很亮很亮，是很远的星星，它是红巨星。那它很亮，它穿过来太多了，它会把你的场里面都是那种我们不太在乎的恒星，所以稍微偏离一点点，所以 red giant 红巨星的就没那么多。它同时可以看100万颗星，它挑了17万颗，14到17万颗来监测。然后下一个问题，大家问的问题就是为什么这个天空这个区域选在北半球？ OK， 有没有要回答这个问题？为什么选在一个北半球看到的天空？这是一个很困难的问题，因为我也不知道答案。有没有人要试试看？为什么要猜猜看？为什么要看北半球？如果你是科学这个任务的 project scientist， 你要讨论为什么要选北半球？来。
大部分的人住在
He said that's because most people live on the northern hemisphere.
More or less right. Yeah, that's more or less right. The team, the Kepler team, is in the northern hemisphere, and the telescopes that they use to study these stars. So if Kepler finds something, and we say, hey, I want to follow that up, I want to observe it, we want to be able to use their northern hemisphere telescope. In particular, we want to be able to use the Keck telescopes, which are in Hawaii. And there's a little bit of a political thing, because there are telescopes in the southern hemisphere. Those belong to another team. So there are sometimes decisions are made for political reasons. So this is what's called the first light image from Kepler. So every telescope has what we call a first light image. It's the first light going down the camera. And so this was taken, you'll see this is April 8, 2009, 2 days after the launch. The dust covers come on. And this is the first image. You can see the 42 detectors, and you can see stars here. There are lots of stars. If we blew up on this, you'd see stars essentially everywhere. And from this, there are 170,000 that were picked out that would be studied in detail. We're going to come back to this, but there's a reason why there's this particular funny pattern to the layout of the detectors. You might ask, why are they not all lined up in the same direction? There's a symmetry to this, and there's a reason. there's a design. I'll come back to that. I don't know if you.
会说，他等下会解释为什么这个东西不是对称，比如说，因为你把很多晶片拼在一起，为什么不干脆就全部是直的啦？啊，为什么会有一些这样子的设计？
So this video. This is an artist's impression of Kepler and the Earth. I'll show this a couple of times. One thing you'll notice is that Kepler is gradually falling farther and farther behind the Earth. But it is in an orbit like the Earth. It's not orbiting around the Earth, it's orbiting the Sun. Kepler is away from the Earth, away from the glow of the Earth, and the Earth doesn't get in the way. Show that again. You'll also see that Kepler's always pointing off in the same direction. Every 3 months, the Kepler spacecraft rotates so that the solar panels are pointed toward the Sun. The orbital period of the Earth, of course, is 365 days. The orbital period of Kepler is 370 days. So every Earth year, Kepler is getting a little bit farther and farther away from the Earth.
这个很有意思啦，各位，绕着地球的绕着行星的叫卫星嘛，所以我们人造的叫人造卫星，对不对？所以 Kepler 不是人造卫星来的，它是人造行星，因为它跟着地球的轨道是一样的，它是照太阳的，所以为什么它不会被地球挡到？对，还是一个很特殊的轨道。另外一个就是它刚刚很有意思，就是因为它是对着那个太阳，对着那个目标的场要看。 那每3个月呢，它要翻身一次，因为它的虽然它指向同一个地方要看，可是它太阳能板要对着太阳，它才能够充电嘛。那但是因为周期不太一样，它的周期比地球绕太阳的周期长，所以它会慢慢距离就拉开了。
So I'll go back to this picture of the camera. And as I just said, every 3 months, the spacecraft rotates 90 degrees. And then you can see why it has this kind of symmetry. If you rotate this 90 degrees, this star will end up in the same position on a different chip, on a different detector. The only place where that doesn't work is in the center here. But in all of the other cases, the stars end up in the same orientation on one more chip. You know, just keep rotating around. So there are a number of critical Kepler science questions. These are the goals. These are the scientific goals of the Kepler mission. They are, what is the frequency of Earth-sized planets in or near the habitable zone of Sun-like stars? So we'll talk about this. That means, how common are planets like the Earth? Are planets like the Earth common or rare? Another question is, what is the distribution of planet sizes? Are there lots of big ones and a few small ones, or mostly big ones? What about the distribution of semi-major axes? Semi-major axis means the size of the orbit. Are mostly things in small orbits or in large orbits? Are there many planets in multiple star systems? What can we tell about different kinds of planets? And are some of these properties related to the properties of the stars themselves?
这边在问一些Kepler 这个任务一些最关键的一些科学问题。那这地方投影片比较难，我稍微讲一下好了。第一个当然回答就是说，像地球这样的行星 ，frequency 就是周期嘛，会有多长出现？是很多还是很特殊？像我们别的行星系统是不是很少有像地球这样子啊？所以说在 habitable zone， 在这个可居住范围之内的。 尤其是在太阳这种恒星旁边，在可居住范围之内的，像地球这样大小的行星，也就是像地球了啊，到底是很多 terrestrial 就是地球的意思，类似地球的行星，类地行星是很多很 common， 还是很稀有。然后这些行星它的大小的分布 是大的很多，还是大的比较少，还是怎么样？它的数量是怎么样分布的 ？Semi-major axis 就是半长轴啦，就是轨道的就是距离，这些恒星距离它的母恒星的距离又是怎么分布的？是远的多呢，还是近的多呢，还是怎么样啊？这个是所以都是这些所谓的 distribution 分布，也是一样 frequency 出现个数的多少，以及它的轨道的分布又是怎么样，对吧？尤其是在多星的系统里面，如果太阳有一个兄弟，也就是太阳是双星，那我们地球会不会在这边？这是一个很好的问题啊，因为天上的恒星多半都是双星系统，在双星系统里面的行星呢有没有不一样？然后呢，除了这些半长轴的分布的 albedo 是它的反光能力啦、大小啦、质量啦、密度啦，那么这些行星到底它的分布总而言之就是去看看这些行星的性质，对不对？然后最后一个问题，这些行星的性质跟它的母恒星的性质有没有不同？大的恒星、小的恒星，它旁边的所形成的行星系统有没有什么差别？
So now I'm going to start talking about actual results from Kepler. It's up to you. Yeah.
好，我们下课休息一下，因为要进到另外一个题目。现在要开始讲开普勒找到的各种奇奇怪怪 wonders， 要开始找这种奇奇怪怪的行星。我们下课10分钟，10分钟以后回来。